We're going to do a couple of examples today looking at reflections over the y-axis. And first I'm going to start with this equation, y equals 3x plus 5. The original graph would go through the point 0, 5, and then 1, 8, and then back in the other direction it would go through negative 1, 2, negative 2, negative 1, etc. This would be our original graph of y equals 3x plus 5. Now suppose we wanted to reflect this over the y-axis. That would mean that our axis of symmetry would be the y-axis itself. So we want to take every point that we just graphed on the original line and reflect it around the x-axis. So there's originally a point at 0, 5. Because that's on the line of symmetry, the y-axis in this case, it's not going to go anywhere. Then there was the point at 1, 8, which we can reflect to negative 1, positive 8. There was a point at negative 1, positive 2 that we can reflect to positive 1, positive 2. This point gets reflected over here, and if we continue, we can see the pattern. We can see the pattern developing, and here is the line we get, having reflected over the y-axis. So let's try writing the equation of that line. So the equation of the reflected line. Let's put it in y equals mx plus b form, like the original equation was. In this case, the y-intercept is still the same. It's still positive 5. Now the slope, though, is down 3 over 1, down 3 over 1, down 3 over 1. So our slope is negative 3 over 1, or negative 3. So our new equation is y equals negative 3x plus 5. And what happened there gives us a hint about the rule for doing reflections over the y-axis. To reflect over the y-axis, you want to take the x value and plug in a negative x instead. If we took y equals 3x plus 5 and plugged in a negative x value, it would simplify to negative 3x plus 5, which is in fact the equation we found when we did every point by hand. Let's apply that rule to another function and see if it does actually create a reflection around the y-axis. Let's have y equals the square root of x as our original function. So if you plugged in x equals 0, there's a point at 0, 0. If you plug in x equals 1, the square root of 1 is 1. If you plug in x equals 4, and I'm skipping to 4 because I know that's a perfect square, if you plug in x equals 4, y equals 2. And if you plug in x equals 9, y equals 3. Okay? And I've plugged those points in because I know that they are perfect squares and they will get me whole number answers for y. So the rule for reflection over the y-axis is to plug in a negative x for x. So that would get us y equals the square root of negative x. So let's try this again. We're going to plug in the same numbers as last time and see what happens. Well, if we plug in 0, we get negative 0, which is just 0, right? 0 is not a negative or a positive, and the square root of 0 is 0, so that one works fine. Well, what if we plugged in 1? Well, then we would get the square root of negative 1, and we know that that's not defined as a real number. So we're not going to be able to plug in 1. The same thing's going to happen when we plug in 2. The same thing's going to happen when we plug in 4 or 9. It's going to become a negative number under the square root, and that's going to be an issue. So maybe instead of plugging in positive numbers, we should try plugging in negative numbers instead. And I suggest that because I know that negative means opposite, and right now we have something negative and we want the opposite of that under our radical. So let's try plugging in negative 1. So y equals the square root of negative x. Well, x is negative 1. So this turns out to be positive 1, and the square root of positive 1 is 1. Let's try the same thing with negative 4. Y equals the square root of negative x, so negative negative 4. That turns out to be positive 4, and we get 2. The same thing will happen with negative 9. The negatives will cancel. Negative of negative 9 is positive 9, so the square root of positive 9 is positive 3. So now if we graph these, we still have a point at 0, 0. Now we have a point at negative 1, 1, negative 4, 2, and negative 9, 3. So now our curve goes this way, pointing to the left. We were hoping that this would be a reflection over the y-axis. Well, if that y-axis is our axis of symmetry, then yes, because this point corresponds to this point reflects over the y-axis to this point, and this point reflects over the y-axis to this point. Plugging in a negative x for the x value gets you a reflection over the y-axis.